So this video is going to focus on a calculation that we have already done. You just didn't realize that you'd done it before when we did the copper lab, is what we call percent composition. And so this is a way to tell when we think of law of definite proportions, what we did in Unit 1, it tells you that you have a different compound if the percentages don't come out to be the same. So percent composition of each element in a compound, grams of an element over grams of a compound times 100 times 100. So I'm going to do two examples that are more traditional way of doing percent composition. I'm going to show you a different way from lab data. So if I just give you a formula like NaCl, what you do is you look up on the periodic table the molar masses. You're given no other information. If I look up sodium, we're going to round that to 23. And if I look up chlorine, we're going to round that to 35.5. So 23 grams, and this is 35.5 grams per mole. So that's going to add up to 58.5 grams per mole as the molar mass of NaCl. So again, percent of grams of element over the grams of the compound. So if I want to know the percentage of sodium, I could take the 23 grams over the total 58.5 and multiply it by 100, Because again, when we talk in percentages, most people know what you're talking about. So if I do the math, it comes out to be 39.3%, and I could do the same for chlorine. But all I have to do is really take since I only have two elements, I could take 100 minus 39.3 and get the percentage there as well. Now, again, your number should add up to 100%, but you might be a little off because of, again, the rounding we're doing with the molar masses. So if that happens, that's not a big deal. So it's around 60.7%. So again, it should come out to be 100%, but it might be 99.9 or 100.1. That's not an issue for the calculations we're asking you to do. So pause the video and see if you could do the mass of, the percentage of calcium in there, the percentage of phosphorus, and the percentage of oxygen. And then when you come back on, I will show you the answer. So the molar mass of the calcium phosphate is around 310.3. And again, just show me all of your work when you have these types of problems. I have 3 calciums in the formula, so 3 times the molar mass. I get about 38.8%. Phosphorus, there are 2 phosphorus, so 2 times 31 over the total, about 20%. And then 2 times 4 is 8 oxygen, so 8 times 16 over 310.3 times 100 is around 41.3. And again, this doesn't come out to be exactly 100, it's actually 100.1%, but that's going to be fine for the calculations that we are doing. So the additional one that you're going to see with percent composition kind of goes back to the copper lab that we did in Unit 1. So I want to do a couple examples of this so you can see the difference. So what if I gave you the following data? I had 5.7 grams of sodium and 8.81 grams of chlorine. So I want to know the percentage of sodium and the percentage of chlorine. Okay, so I'm not going to use molar masses here. I'm not going to convert to moles or do anything like that. And we haven't shown you that yet. So instead, I'm going to take the 5.7 grams. I'm going to add it to the 8.81 grams, and I get a total of 14.51 grams, which is of the whole compound. Okay, again, we are assuming there are no other elements there. So how much sodium is in there? I'm going to take the 5.70 over the 14.51 and multiply it by 100. And I'm going to get the 39.3%. And by the way, that's going to agree with what we got in the previous problem. Okay. And chlorine, 8.81 over the 14.51 times 100 is going to be approximately 60.7. which we got again previously, because we know that the formula is NaCl. We know we have 1 Na and 1 Cl every time we have that compound. So what about this problem here? So I have 222.6 grams of sodium and 77.4 grams of oxygen. Again, I'm going to pause the video, and in a moment you will see the answer, but why don't you pause the video and try it on your own? So again, I just took the amounts that they gave me and I added them up, and they added up to about 300 grams. I took the sodium over the total, multiplied by 100, and I got around 74.2. I took the 74 over the 300 to get about 25.8%. So a way you could kind of mentally check this is to think about, well, what kind of formula would I make between sodium and oxygen? So remember, sodium is in that first column. So sodium is going to have a +1 charge and oxygen is going to have a -2 charge. I'm going to write that underneath. So sodium is a +1 and oxygen is a -2. So how would I get that to 0? I would write Na2O. And if you did the molar mass of sodium, which is 23 times 2, and did the percentage, you would see you would have a higher percentage of sodium than you would oxygen. This percentage would work out exactly with this formula. And want you to relate it back to the copper lab we did in Unit 1, okay? We had copper 1 chloride, and we had copper 2 chloride. You just didn't know it at the time. We had two different populations that showed up. Well, if I do the copper 1, I have 1 copper, which is 33.5. And if I add it to chlorine, which is 35.5, I get around 134.5 grams, and multiply it by 100, I see that copper in there is about 47.2%. Again, copper 2, 63.5, the difference is going to be I have 2 chlorines, so it's going to have, this should be 99 grams. And that should be a mass of 64.1%, looking at my notes wrong. And this one, I have 2 chlorines, so this molar mass is going to be bigger down here. So the amount of copper is going to be 47.2%. Because again, you only have 1 copper with 1 chlorine. This percentage should be pretty close to, not equal, but definitely closer to 1-to-1. So if you remember back to our data, we had one population that had a certain percentage that was in the 60s, 70s. Then we had another population that was around the 50s. So we were doing percent composition back in Unit 1. You just didn't realize we were doing it. Now we know molar masses, and we could do these compounds with molar mass as well. So this way is with grams that we get from experimental data, and then we could also do it using molar mass, which I showed you in the previous problem. So that is, again, percent composition. That is percent composition.